So let's try to solve the next question, which is called calendar cubes. We have two custom-made dice. Instead of 1 to 6, we have single-digit numbers on the faces of the dice, so that every morning we can arrange the dice in a way that the two faces show the current day of the month. You must use both dice. So 0 1 to 9 must be shown as 0 1 to 0 9, but you can switch the order of the dice if you want. Okay, that's fine. What numbers should you put on the faces of each of the dice to achieve that? So this is basically individual numbers on individual dice, not that you're making, like, let's say a dice with let's say you're trying to make 0, so this on one day, this on one day. This is not the case. Basically, that's something that you might be confused with when you have read the first part of the problem, but then the problem itself says that it should be something like this. Let's say 19 will be shown as 1 9 and so on. So firstly, let's try to see that, let's assume that we're not changing the order for now, because else there are too many possibilities. Let's check what digits do we need for sure in the dice. So if we're going to put this die on the first place, we'll obviously need 0, right? We'll obviously need 0. But also, if we're going to start with 0, let's look at the numerical digit, right? It's 0, we need 1, we need 2, we need 3 at max, right? So we will need this for sure, 1 2 and 3. And for now, let's not fill the other two gaps. Let's try designing the other die, and let's see what is missing from our current die. So 0 1 2 3, that's all we need. And the second place, what can come? Well, anything from 0 to 9 can come in the second place. 1 2 3 4 5 6, yeah. So anything from 0 to 9 can come in the second place. So beware of that. Think along those lines. So if anything can come, let's right. So how can we, what can we do? Think of it. What numbers are we left with? Let's look at the numbers we're left with. If we need 0 to 9, well, we will never have a 0 0 date. That's not going to happen, right? So should we not give the other die 0? What's the harm with that? Let's say we're not giving the other die 0. Let's say we're going to make 1 2 3, right? We're going to make 1 2 3, and then let's say we're going to make, we've not given 4 and 5 now. Let's say we're going to make 4 5, 4 5 6, just for the heck of it. And what's left? We have 7 8 9 left. Well, we don't really need a 7 or you can always use 6 as a 9, because it's inverted 9, so that we're good with. But can we put 7 and 8 here? Is there something wrong with these combinations of dice? Let's just check. We can easily make 0 to 6, but we can't really have 0 7 and 0 8, right? So this is the assumption that the second dice does not need a 0 is wrong, because we need 0 7 and 0 8, right? So for that, we will have to also add a 0 here. That's a necessity. So I'm going to add 0 here. And if we're going to add 0, then we have 1. Do we need 1? Yes, we need 1 in both the dice. Do we need 2 in both the dice? Yes. But do we really need 3? Well, we have 2 in the second die, because you have something like 11 and 22 coming up. But do we really have 33? No. No date can be 33. And as for 30, well, you have 0 here. 30 is being covered. So 10, 20, 30 is being covered. 11, 22 are being covered. We don't need 33. So we don't really need a 4 or a 5. Right? So can we put 4, 5, 6 here? 7 and 9. Is this die comprehensive? Is there something missing here? Let's just check. We can make 0 1 0 2 0 3, 0 4 0 5 0 6 0 7 0 8, and also 0 9. Yeah, so 0 to 9 are covered. But let's say 11. Can we make 11? Okay, 12, 13 is possible, 14 is possible. I'm just going to show marks, I think. So 11 is possible, 12, 13. Sorry, 13 will be this way. 13, 14, 15, 16, 17, 18. Well, they are really possible. 19 is also possible. And if that's possible, then 20, because 2 is here, 21, 22. You can always have a 23. So we have since we have that and 30 is coming here, well, I think we've covered all the possibilities, so we can design a die like this. What have we kept in mind? Well, we've made sure that these three digits are repeated everywhere. These are the unit digits, and well, the rest, other than that, we've just taken care of the fact that 9 and 6 are inverted, because a printed 9, right, it looks like the inverted version of a 6. If you see, this is what this is what a printed version of a 6 looks like. So I think we're good with this problem. If you have any doubts, let me know in the comments below. Thank you.